Hello everyone, welcome back to Maths by Harshit. I hope you are doing well. In this video lecture, I'll discuss chapter continuity of exercise 5.1, and in exercise 5.1 we will discuss question number 1, 2 and 3. So without further ado, let's get started. What the question given here? Question is prove that the function fx equal to 5x minus 3 is continuous at x equal to 0, at x equals to minus 3 and x equals to 5 we need to prove. I will prove for 0 and minus 3 and you need to prove for x equal to 5, okay, because same procedure we need to follow. So what we need to prove here? Continuous at x equal to 0. How we can prove? Function is 5x minus 3 is given. Function is 5x minus 3 is given, and here we need to check at actually first part we will take x equal to 0. Okay, so here we need to evaluate LHL, then its RHL at x equal to 0, and then the function value. Three things we need to check. Are these three things equal? Then we say then function is continuous. If any one of them is unequal, okay, suppose LHL, RHL both are equal but not equal to f of 0, then we say function discontinuous. If LHL not equal to RHL, then also discontinuous. If LHL equal to f of 0 but not equal to RHL, then it is also discontinuous. Okay, like that we have 4 to 5 cases. Now here LHL, what is LHL? LHL is limit x tends to 0 negative f of x, limit h tends to 0 f of 0 minus h you have. Okay, limit h tends to 0 f of minus h you have, and here limit h tends to 0. What is f of minus h? Complete function is defined by this one, this by the equation 1. So what we have? 5 of minus h, 5 of minus h minus 3. If you apply limit, we get minus 3. Okay, so this is your LHL. This is your LHL. This is equation number 2, you can assume. Okay, now we have here we have RHL. What is RHL is? Limit x tends to 0 positive f of x, limit h tends to 0 f of 0 plus h, limit h tends to 0 f of h, limit h tends to 0 5h minus 3, and what we get here, that is minus 3 again, and this is your RHL. Third equation. Okay, now we need to evaluate the function value. F of 0 is 5 into 0 minus 3, we get minus 3. This is your fourth equation. Okay, this is our f of 0. Now we can imply that from first, second and third we have LHL equal to RHL equal to f of 0. If these three things are equal, then we say f is continuous at x equal to 0. I hope you understand this thing. Okay, now the next part is at x equals to minus 3 we need to check. At x equal to minus, same procedure we need to do, same dicto procedure. Okay, so here I will do second part. LHL again. What is your x? X is here minus 3, and function value I will write it again. What we have? Function is, our function is 5x minus 3. Yeah, 5x minus 3. our function is 5x minus 3. So here again LHL we need to find limit x tends to minus 3 negative minus 3 negative f of x. Okay, limit h tends to 0 f of minus 3 minus h, limit h tends to 0 f of minus 3 minus h we can find by this one, 5 of minus 3 minus h minus 3. Okay, now we can need to multiply by the 5 inside, limit h tends to 0, 5 3 15 minus 5h and minus 3. So ultimately what we get, minus 18 from here if we apply the limit. This is our LHL. This is our equation number star 1 we can say. Okay, wait, now we can find our RHL, limit x tends to minus 3 positive f of x. Okay, I will tell you what is the meaning of this one. Okay, after completing this thing, this second part, limit h tends to 0 f of minus 3 plus h we have, limit s tends to 0 minus 3, that will minus 3 plus h and minus 3 you have here. Okay, now limit h tends to 0 minus 18 plus 5h minus 3. If we apply limit again we will get minus 18 here, and here it is your RHL. Star 2 you have. Okay, now f of minus 3 if we want to find, how we can find, 5 into minus 3 minus 3 minus 15 minus 3 minus 18, this is our f of minus 3. Okay, this is our star 3. So here we can say that from star 1, star 2 and star 3, LHL equal to RHL equal to f of minus 3, and if we have this thing then we say f is continuous at minus 3. Okay, I hope you understand both the parts. Okay, so the third part is your homework. What is your third part? The third part is at x equals to 5 you need to check that function is continuous. We need to prove. Okay, now what is the meaning of this one? Procedure we know, procedure we completed already, but what is the actual meaning of this one? Okay, see, suppose this is your, here we have a 0, this is our 0 part. Okay, this is 0. Okay, LHL means when x moves towards 0 from the left hand side, okay, this negative represent that we are moving towards 0 from the left hand side. Then our task is or to observe that where this fx moves actually. Okay, and if we are evaluating RHL, it means when x moves towards the 0 from the right hand side, that is positive part, this positive will show that we are moving towards 0 from the right hand side, and our task again is to check where fx moves. Okay, if in both the cases when x moves towards 0 from the left side or from the right side and fx moves towards a same point, okay, here as it moved toward the same point, what we get, minus 3 and minus 3 we are getting. It means fx moves towards minus 3. Okay, whenever x moves towards 0 from the left side or right side, but fx moves towards the same number, that is minus 3, and function value also minus 3. Hence we say the function is continuous. That is the actual meaning. Okay. Now next question we are coming. Second question is examine the continuity of the function at x equals to 3. Same procedure we need to follow. The procedure is fx we already have. Okay, I will directly find LHL. Okay, limit x tends to 3 negative f of x. These two steps, first step and this is second step, limit h tends to 0 f of 3 minus h. Okay, and here limit h tends to 0. How we can find? 2 into 3 minus h whole square minus 1. Okay, now we need to open inside part. Limit h tends to 0, 2 here, 9 plus h square minus 6h. What we have? 9 plus h square minus 6h minus 1. And if we apply limit h tends to 0, okay, what we get? 18 plus 2h square minus 12h minus 1. Okay, so directly now we can apply limit. Simply what we get? 17 we will get. 18 minus 1, 17. So it is your LHL. That is your first equation for this question. Okay, now we need to evaluate. What do we need to evaluate? We need to evaluate here our RHL. Okay, RHL, how we can evaluate? Limit x tends to 3 positive f of x, limit h tends to 0, 3 plus h, limit h tends to 0, 2 times 3 plus h whole square minus 1. Understand? So again we need to open same as before. Limit h tends to 0. Here we have a 2, 9 plus h square plus 6h plus 6h minus 1, and again we have limit h tends to 0, 18, 2h square plus 12h minus 1. Okay, and if here we are evaluating this limit directly, what we are getting for RHL is again 17. Okay, this is our second equation. Okay, now the third part is the also mean f of 3 we need to evaluate. So what will be? 2 into 9 minus 1, again it will be 17, and this is your third equation. Okay, so from first, second and third, from first, second and third, we have LHL equal to RHL equal to function value at 3. Hence, if these three things are equal, f is continuous at x equals to 3. Now one more thing I need to tell here. From first and second, we observe that the common thing here it is, in the first question, what we have? In the first question we have the polynomial is given of degree 1. Okay, and domain of this polynomial is complete R. Domain for this polynomial is complete real number. Okay, so we have a result. If suppose this question came in 1 mark, then no need to do like that LHL, RHL and f of 0 you need to find. what you can do, you have a polynomial, so just simply we have all the polynomial, all we have a result, all polynomials are continuous in their respective domain. Now two things we have, either domain is given or a point is given, or maybe they are saying that discuss the continuity of the given function. If they are saying discuss the continuity of the given function, then we need to prove in general by taking a simple arbitrary real number. Okay, but here they are fix x equal to 0, we need to check, x equal to minus 3, we need to, x equal to 5, we need to check. So simply we can say that, suppose in M1 mark question they are saying that is this function fx equal to 5x minus 3 is continuous, and A option continuous at 0, continuous at 3, continuous at 5, and all of the above. So all of the above we can say. Why? Because that function is continuous for all real number. Okay, and if they are asking for some real number that it is continuous or discontinuous, then we can say it is continuous only, because it is never discontinuous. Okay, so simply by polynomial, here degree 1 is there. In the second question, here we have a second question. Here we have this one, second question. In this one we have a degrees 2, and at 3 they are saying, it may possible they are saying that find the set of discontinuity of this function. So discontinuity of this function is 0. How many number of elements is 0? Okay. Why so? Because this function is continuous on complete R. Okay, so there is no point of discontinuity. So all the polynomial you can feed in your mind that all the polynomial function are continuous everywhere. Everywhere means in complete R. Okay, yeah. And if they are asking the question in 2 marks or 3 marks, then you need to prove like LHL, RHL, and like that function. Okay. And throughout, whenever as we are doing more and more question, I will tell you the trick what you need to do in a particular that type of question. Okay. But here if they are saying like that, then you need to find LHL and RHL. Now here examine the following functions for continuity. Okay, again here see. Now here they are saying examine the following function for continuity. See, it is a polynomial of degree 1. Okay, so first of all we need to find its domain, and then on its domain we need to check is it function continuous or not continuous. Okay, same thing here, it's a rational function, it's also a rational function, and it is a modulus function. Okay, so I will prove for all one by one. Okay, and I'll tell you, actually this thing we already proved, but in general I didn't prove in above. So here I will prove how you can proceed. So A option, A part, f of x minus 5 we have. Domain for this function is complete real number first of all. Okay, on this real number side we need to check is this function continuous or not continuous. So what I will take, let A is any real number. Okay, and now I will find LHL for this real number A. LHL limit x tends to A negative f of x. I said na, these two lines are evergreen. Limit h tends to 0 f of A minus h. Here limit h tends to 0, what we have, A minus h minus 5. A minus h minus 5, and if we apply limit, what we get, A minus 5 simply. This is your first equation, LHL. Okay, I hope you understand this thing. Okay, now the next one is your RHL. RHL is limit, again x tends to A positive f of x, limit h tends to 0 A plus h, limit h tends to 0, what we have, A plus h minus 5. this we can use star 1. Okay, and here we have, if you apply limit a minus 5, we are getting, this is your RHL, second equation. Now same as that, function value at a, that is a minus 5, and this is your third equation. So from first, second and third, from first, second and third equation, what we observe, what we observe that LHL equals to RHL equals to function value at a. Okay, hence the function is continuous, implies f is continuous at a. See, a is arbitrary real number I choose here, so it means that how we can write this thing, this thing is complete for a. Now as a is any arbitrary, what we need to write, arbitrary real number for which f is continuous at a. So implies that for all a belongs to R, for all a belongs to R, f is continuous at a. Hence f is continuous on R. Understand? I think better understand, huh? If you have any doubt in any step, you can ask me. Now we are moving towards our second question, that is rational function fx equals to 1 upon x minus 5. Actually, why I am saying it is a rational? Because it is in the form of fx equals to px upon qx format, where px and qx both are polynomial. Here px is a constant polynomial and qx is a polynomial of degree 1. It is same as that fx in the first part. Okay, so the function is 1 upon x minus 5, huh? Now the second part, b part, we have f of x equals to 1 upon x minus 5 we have, where x is not in the domain. Obviously if x equal to 5, then it will be not defined. What we get, it is not defined. So one more thing here. First of all, I will tell you its short trick. The short trick of the rational function is, suppose you have any function fx, okay, fx is your px upon qx. If you have px and qx both are polynomial, okay, so first of all find its domain. What its domain? Domain of this function is, domain for this function is real number minus all those points, all those real number for which q of x is 0. This is the domain. And on its domain, if the domain is not specified, okay, examiner itself not giving anything, so what is the set of content, largest set of content is this complete df, okay, because the function, the polynomial function is continuous in its respective domain. Okay, this is the short trick you need to think. What you need to do, just remove all those points where fx is not defined, and where fx is not defined, where qx is not defined, okay, where qx is 0. Okay, so remove all those points and you get the set of continuity. I hope you understand. Now how we can proceed here? First of all, domain you get, okay, so same thing we need to do here, same dicto things. What we have, yeah, let a belongs to df. From df I will take, okay. Now From df I will take, yeah, and we observe that, yeah, here you can listen. We observe that LHL, what is our LHL? Same thing we need to do, limit x tends to a negative f of x, limit h tends to 0 a minus h, you have limit h tends to 0 1 upon, what do we have, x minus 5 I think so, huh? Yeah, x minus 5 we have, so here we will write a minus h minus 5, and here what is our actually, this one is r minus 5 because only one point we have, okay, so this is our domain, so obviously then a is not equal to 5, here a also not equal to 5, okay, limit if you apply, then what we are getting, a minus 5, and it is defined, why so, because a is not equal to 5 already we have, this is your LHL, okay. Now what we have RHL, RHL is limit x tends to 5 positive, sorry, a positive, f of x you have, limit h tends to 0 a plus h you have, limit h tends to 0 1 upon a plus h minus 5, and if you apply limit again we are getting a minus 5, and same as it is, a is not equal to 5. This is your RHL, and the function value at a 1 upon a minus 5, okay. This is your first equation, second equation, and third equation for only this part, okay. So here again we need to say from equations first, second, and third, what we have, LHL equal to RHL equal to function value at a, understand? So this is your function continuous at a, what we have, this function is continuous at a, we have f is continuous at a, okay. Now you can observe that, see, I'll change the color, observe, a does not belongs to df, as, sorry, uh, 5 does not belongs to df, as f of 5 is not defined, and we observe that to prove that f is continuous at any point we need to use the value at that point also, but here f of 5 is not defined, so simply we are saying that f is discontinuous at 5. Why so? Because in continuity we are interested in the function value also, and here the function value we can't find, so hence simply f is discontinuous, okay. That's why I gave the short trick that suppose you have a fx and you have a px upon qx, that is a rational polynomial, rational function you have, px is a polynomial, qx is a polynomial, what you can do, just remove, to find the df, what we need to do, from R we need to remove all those points where the q is 0, okay. So simply you need to remove all those points, and its set of continuity point, set of continuity point is also same, set of continuous point is also same as that of df, okay. That is your short trick for 1 marks, okay. And how many point it is discontinuous, as many the degree of the qx, as many the real number for which qx is 0. Okay, no degree. Degree give at least, at most we have 5 discontinuity point, but it may possible if the polynomial came like that x square plus 1, then it does not have a real solution. Okay, so we can't do anything at the time. Okay, but if we have x square minus 1, then we have two real solution, and hence we can say we have two points of discontinuity if qx is x square minus 1 type. Okay, now the next question we are moving. What is our next question? um, Here we have x square minus 5 upon x plus 5, x square minus 5 upon x plus 5 we have. Okay, I think you can do easily. Okay, third question it's your homework, fourth question I will do. Why I am saying this thing? Because it is same as that. Okay, it is same as that. You need to do some hard work now. Okay, what else I will do? Because it is a new, it's a new question. Okay, it's a new question. Okay, you have fx mod of x minus 5 we have. Okay, now is there any some restriction? Check one time only. Is there any restriction they give, or just simply mod x minus 5 they are giving? Yeah, simply mod x minus 5 they are giving. It means first of all we need to find the its domain. Okay, how we can find its domain? Domain of this function, we can see that for any input if we are giving here, it will be coming here, and there is no restriction or there is no foundation in putting the any real number. Okay, hence the domain for this function is complete R. Okay, and one more thing, if I will draw the graph of this function, then what it will comes, it will be like mod x minus 5. It means at 5 it will be 0, so the graph is at 0 we get 5, so 5 5 like that, so graph is like that. Okay, v shape graph, and sharp edge we get at 5. Okay, so this is your mod x minus 5 graph. Okay, and the domain of this function is complete R. Here it is also moving upward direction, and here it also moving upward direction. Okay, now as x moves toward the minus infinity, as x moves towards the plus infinity, we have this thing. Okay, now from the graph we can observe that without lifting our pen we can draw the graph of f of x mod of x minus 5. So hence we can say that the function is continuous. If we have a 1 mark question, so simply you can draw the graph and you can see is there any breakage? No breakage, hence the function is, because we can draw easily the graph of mod of x minus 5. Okay, but here as if the question came in 2 marks, 3 marks, then how we can proceed? The same as that. First of all we need to redefine it. How we can redefine? The mod of x minus 5 will be, it is same as that x minus 5 if x minus 5 is greater than equal to 0, and if x minus 5 is less than 0, it will be minus of x minus 5. This is your f of x. Okay, so again redefine it. What we have here, we have x minus 5 inequality we can solve easily, so we get x greater than equal to 5, and here if x is less than 5, then we get minus of x plus 5. This is your mod of x minus 5. This is your f of x. Okay, now same thing we need to do. Okay, what we need to do here, LHL we need to do, RHL we need to find, and function value at 5 we need to find. Okay, and before 5 it is continuous, after 5 is also continuous. How? I'll tell you. See here, see now how we can prove. Part A I am taking here. Okay, the first part, no, this one you can take the first part. If A I am choosing, okay, A belongs to DF, that is complete R, and restriction is there if A is less than 5. See, it has 3 things: before 5, at 5, or after 5. Okay, 3 things we have: first part, second part, third part. So same thing I will do here. Now before 5 you can see that same function is defined, that is minus x plus 5. It is a polynomial, na? polynomial or not. And we already discussed that every polynomial is continuous um, in their respective domain, and here domain is defined x less than 5. So we can simply writing that clearly because here we have a 5, so a is less than 5, so guarantee a is not equal to 5. A should be here, a may be here, but should be there is a distance na here. Okay, a should maybe here, a may be here, or maybe be here, a may be anywhere. Okay, so here I'm saying that fx, what fx will define for LHL and RHL, fx is minus x plus 5. Okay, clearly fx equal to minus 5, which is a polynomial of degree 1, and hence it is continuous at a. Okay, understand? Same thing we can do for the second one, that is if a belongs to df equals to r, but restriction is if a is greater than 5. A is greater than 5, a equal to 5 I'm not taking, a is greater than 5 because breakage at 5, so it may possible that they may be discontinuous at 5, or may not be they may be discontinuous and may not be discontinuous at 5, but definitely if 5 is here and a is greater than 5, then it should be here, but it should be a distance in between 5 and a, guarantee na? Because a is greater than 5, it may be here, it may be here, it may be anywhere. Okay, so for that clearly the function is same line we need to repeat clearly. Fx is what we have, x minus 5 we have. Okay, and we need to write the same, which is a polynomial of degree 5, and hence it is continuous at a. Okay, so here we prove that a belongs, for all a belongs to r minus 5 in our part according to from first and second. First is this one, second is this one. Okay, from first and second, what we prove that a, for all a belongs to r minus 5, f is continuous at a. Now the main task is to prove that the continuity at 5. Now the third task, here you have a function is, again I'll redefine it, mod x minus 5 you have. Okay, how we can define, you have x minus 5 minus x plus 5 we have. Okay, and the first piece is for the greater than equal to 5 and it is less than 5. Okay, so now we are at exactly at 5. Okay, exactly at 5. Now here LHL I need to do, LHL is limit, because it is piecewise defined, so we need to move through LHL RHL. Okay, at 5 it is piecewise defined. First piece we have this one, and second piece we have this one. It is a piecewise function. Limit x tends to 5 negative, f of x, limit h tends to 0, f of 5 minus h, because we are on the left side. When x moves towards 5 from the left side, our task is to check, our task is to where fx moves actually. Okay, we have a graph also, here we can do a graph. Okay, when x moves towards 5, actually our task is to fx, where fx moves. See that fx moves towards 0, but here we can observe by the graph, here we can prove simply limit h tends to 0, we can put 5. See, 5 minus h coming from this one, because h is a very small positive quantity with respect to 5. It should be right to the origin, but it is on the left of the 5 always. So what we have, 5 minus h minus of 5 minus h, wait 5 minus h plus 5 we have this thing, and if we apply the limit, what we get, minus 5 plus 5, 0 ultimate, that is your LHL. And we already seen, observe it from the graph also. Okay, and here from the RHL, what we are doing, limit x tends to 5 positive f of x, limit h tends to 0 f of 5 plus h. It means that when x moves towards 5 from the right side, our task is to observe where fx moves. See, the fx also moves towards 0. Okay, so here limit h tends to 0, but we need to prove, we need to show, and 5 plus h is lie in the first piece. So what we have, 5 plus h minus 5. Okay, and if we apply the limit, 5 minus 5, again we get 0. This is our RHL. Okay, this is our RHL. Okay, this is our first one, this is our second one, and the main is f of 5. F of 5 we can find by the first branch. Why? Because they are itself saying that it is from the first branch we need to obtain. Okay, what we have actually, f of 5, we have f of 5 is 0. 5 minus 5 is 0 also. So this is your third one, this is your second one. Okay, what is happening? Wait. Okay, but we observe that our f of 5 is also 0. Hence, LHL equal to RHL equal to the function value at 5. All three are same. Hence, the function is continuous. This is your second. F of 5 is 0. Leave it this one. Okay, f of 5 is 0. Hence, the function is continuous at 5 also. So before 5 it is continuous, after 5 it is continuous, at 5 is also continuous, and the function is continuous throughout the complete domain, that is complete R. Okay, I hope you understand all these three questions. If you have any doubt, then you can do comments. I will come back with the new questions of exercise 5.1. Thank you for watching. Please like and share, subscribe.